So section 11.4, we're going to get away from always having to have a vertex at the origin or a center at the origin. And we're going to start it with this problem right here. Now before we do anything, what I want you to do is I want you to tell me what graph you're going to see. Now they've given you a lot of choices here: an ellipse, a parabola, a hyperbola, a generic conic, or no solution. What would you guess? What would be your guess before you click that link on Desmos?
Parabola.
Should be a parabola. Now one of the handouts that I've given you is this one. Which conic am I? If there's only one squared term right here, if there's only one squared term, then it's probably going to be a parabola, all right? In this class, it will be a parabola. So it is going to be a parabola. Let's play with that a little bit and see if we can't whip that into shape so we can determine some more information. Now, generally speaking, you're not going to get quite so lucky as to have a 1 here, which is like perfect for what we need. But I'm going to proceed as if we didn't. And I'm going to move those two terms to the other side. X squared plus 2x equals negative 12y minus 1. Notice that they change sides, they change signs. And the goal here is to complete the square. That is to figure out, well, what do I put here so that the left-hand side is this, and I don't want a square there, I want a square here. The left-hand side has to be the square of a binomial. And I hope you remember that process of completing the square that does that for us. So you're going to take half of the middle term. So half of 2 is 1. And then 1 squared is 1. So I'll add 1 to the left-hand side. Well, I have to add 1 to the right-hand side as well. So that's a 1. Beautiful there. Now, conveniently on the right-hand side, those cancel each other out. So I'm just left with negative 12y. What do I square to get that trinomial? X plus 1, right? So this is in the right form for us to start working with it and determining, say, the vertex. So let's do a little t-table here, our vertex. And I always suggest that we start by making the squared term equal to 0. What value of x would I put in here to make that equal to 0? Negative 1. Thank you. So negative 1. And if I put in a negative 1 there, I would get 0 equals negative 12y. So that means that y must be 0. So awesome. That's our vertex. Yay. 1 point down, another 1 to go. What else could I be looking for? Well, let's think. How about figuring out where the directrix is and the foci is? By the way, what else can you tell me about this graph? Which way does it open? Left, down, up, or right? I guess it might be a little bit misleading because I've got the negative here. Let me divide both sides of this by a negative 1 and get negative x plus 1 squared equals 12y. That one has to open down. So, okay. Let's now click that button here on Desmos, and you can see that the vertex is exactly where we expected it. Negative 1 and 0. Great. There's 2 more things that we need to find. Both of them rely on you finding the value of p. Now, p is the distance between the vertex and the focus. It's also the distance between the vertex and the directrix. But you can find p by setting p equal to the coefficient of your non-squared term. Actually, not p equal to that, but 4p. Now, technically, there's a negative involved. I'm not going to worry about that. If 4p equals 12, then p equals 3. But keep in mind the orientation of this problem. So if my center or my vertex is negative 1 and 0, then I've got to be 3 units down from that point in order to find my focus. So what are the coordinates? What are the coordinates there going to be? Well, I'm not changing anything in the x direction, so it's still going to be -1. But I am going to change things in the y direction. If I go down 3, that'll be -3. Last but not least, I got to go up 3, 1, 2, and 3. And I'll have a horizontal line here. That horizontal line has to have an equation of y equals something. What's it actually going to equal? Oops, wrong one. Right here. There we go. So that's going to be y equals 3. So again, you're a distance of 3 away from your vertex. And that's it. That's it. Now you can play around and keep track of the fact that it's a -3, but I find it easier to keep track of the orientation. I knew that I had to go down 3 because that's going to put the focus inside of the branch of my parabola. And then up 3, y equals 3. Nice. All right. Looking okay on the first one. Let's try the next one. Oh, by the way, there's a few things here that I'm not really fond of. First of all, when you input your answer here, there's a lot of does not exist, etc. Yeah, sorry about that. You know, y equals 3, there's your directrix. -1 and 0, that's your vertex. It's the only vertex. And then your focus is at -1, -3. There's only one focus, so the rest of these things are all just going to be does not exist. So, not much I can do. What's that?
All the boxes like that, but it's going to be a lot of things.
Yeah, there's going to be a lot. The reason they do that is because when they set something up in this form, it can be any of these equations or any of these conic sections. So if it happened to be a hyperbola or an ellipse, then you'd have a lot of this other information. So, you know, yeah, basically that's exactly right. Now, what you should expect from me is something a lot simpler. I'll just give you an equation like this. I'll give you several equations like that and say, what conic section is it, you know? And if there's only one square term, it's going to be a parabola. I'm not going to give us any degenerate conics. If the two terms, the squared terms are opposite in sign, then it's going to be a hyperbola. Great. So those two cases should be pretty easy. If both of these are positive, then you got to look a little further and say, well, is the coefficient of A and C, are they the same? If they are, it's a circle. If not, it's an ellipse. So that's kind of the breakdown of looking at these things and just knowing what conic section you've got. So hopefully that helps.
So
yeah.
A and C were both 25 and positive would be a circle?
Yep. Mm-hmm. Yeah. In fact, let me see if I can't just modify one there. Let me just put in plus, well, in this case, I'll just do plus y squared. And I gotta put a plus here. There you go. Notice that the coefficient here is 1, the coefficient here is 1. So, hey, that turned that into a circle. If I make these different, say let's put a 3 or 2 here and maybe a 3 here, well, it's no longer a circle, it's an ellipse. So, yeah, it's a nice quick way to tell what you've got is looking at the coefficients of the square terms. Awesome. Thanks for the follow-up. Let's try this last one here. And in addition to everything else, I want us to find the equations of the asymptotes. So that's kind of like a big thing here at the end. We'll start by figuring out the center. So the center, and I've said this a few times, you want to figure out, well, what makes the squared terms equal to 0? X and y. So that would be -1 and 5. Okay, so that's our center. By the way, which direction does this open? Up and down or left and right? Opens left and right. Good. So maybe it'd be helpful to rewrite this as x plus 1 squared over 3 squared minus y minus 5 squared over 4 squared equals 1. So I'm going to go to the left 3 and to the right 3. That means changing the x coordinate by 3. So I go negative 1 minus 3 equals negative 4. Now I'm staying at the same y height, so that would be a 5. And then negative 1 plus 3, that gives me 2 and 5. So there's my vertices right there. Now there's a couple other points that I'll use to draw my box, to draw that rectangle. So for the rectangle, I want to move up 5 and down 5 from the center. So let's do that. Rectangle. So I'm not going to be changing the x coordinate. I am going to be changing the y coordinate. And I don't know if I said up 5 or what, but it should be up 4 and down 4 from the center. So it's going to be negative 1, and then 5 plus 4 would be 9, and 5 minus 4 would be 1. So those would be the points that you're going to use to draw your rectangle. In fact, a box through all 4 of these points is going to be our rectangle. Let's take a look at that on Desmos. So I'll shut that off, turn that one on, and let's see, get rid of that as well. So hit the home button. There we go. Let's do the rectangle, and that's looking pretty good. So negative 4, 5, we got that one. 2 and 5, we got that one. Up here, this has coordinates of negative 1 and 8. Let's see, negative, yeah, there's a negative 1 and 8. Something looks wrong there. No, negative 1 and 9, I'm sorry. Negative 1 and 9, and then negative 1 and 1. So those are the points that I use to draw that rectangle. Let's keep going. Find the foci. So for the foci, it's going to be c squared equals a squared plus b squared. And a and the b comes from here, so it's c squared equals 3 squared plus 4 squared, which is 25. So c equals 5. Now the foci are going to lie along the major axis or the transverse axis. That's going to be along the x direction. So I'm going to move 5 from the center to the left and 5 from the center to the right. So the foci are going to be negative 1 minus 5. That's going to be negative 6. And negative 1 plus 5, that's going to be 4. That's going to be my foci. The y coordinate of the center didn't change. So there's my foci, negative 6, 5, and 4 and 5. Perfect. The last thing that I'm going to ask you to do is find the equation of the asymptotes. And my little trick from section 11.3 still works here. And that is asymptotes. We're going to set the 1, we're going to replace that by a 0 and then just solve for y. So x plus 1 squared over 9 minus y minus 5 squared over 16 equals 0. Move that to the other side. X plus 1 squared over 9 equals y minus 5 squared over 16. I would multiply both sides by 16 and get this. And then take the square root on both sides. Now, basically take the square root of everything. On the left-hand side, I'm going to put plus or minus. Square root of 16 is 4. Square root of 9 is 3. Square root of x plus 1 squared is x plus 1. Equals y minus 5. Now there's only one thing left to do here, and that's move the 5 to the other side of the equation. So it's going to be plus or minus 4/3 times x plus 1 plus 5. And that's both of your asymptotes. Now to kind of prove that, I'm going to graph one of those asymptotes here. And what you should see is that the line that I graph will cover up one of these diagonals. So it should be a red line. Bam, there we go. So that's the equation that runs through the diagonal of my box. Okay, comments or thoughts on that? One last little comment here from myself. One thing that happens quite often is that it's easy to get confused about finding C. C is the distance to your foci. And sometimes people mix them up. That is, this is a hyperbola. It should be c squared equals a squared plus b squared. And if you did that, you get the square root of 25 is 5, and great. But if you mixed it up and you did 4 squared minus 3 squared, accidentally using the formula for an ellipse, then you're going to get foci here and here. Square root of 7, and wait a minute. The hyperbola should wrap around that. So if you see something like that, there's a mistake. Likewise, for an ellipse, that distance should be small enough so that your foci lie inside the ellipse. Again, if you use the wrong formula by accident, what you'll see if you take the time to graph it is your foci will lie outside the ellipse. So it should be c squared equals b squared minus a squared. In other words, 16 minus 9 is 7. Square root of that, bam, I get those points. But if I use the formula for the hyperbola by mistake, I get points outside the ellipse. And at that point, you know you've made a mistake. Okay, good luck with this stuff.